Okay, ELE 112, welcome back to Thevenins Theorem. This is video number 3, I believe, and we're going to actually look at using some of the Thevenins Theorem steps to make calculations. Now, I could have sat and flipped you through a lot of pages, but I thought it'd be best if I kept the original circuit up on top. There it is, 50 volts. It's got a load resistor out here that we want to find the Thevenin circuit that drives it. We don't care what that value is because we're not going to calculate the load current and load voltage right now. We're just going to find the Thevenin circuit. This circuit is extremely similar to one of your homework problems. So I recommend that you reverse engineer this process for your own understanding as you work through your homework. So, step 1, here we go. I'm going out of sequence because I can. I'm finding the resistance of the Thevenin first rather than the voltage, and you can do that too. You take a look at the circuit that I redrew, which is a snapshot of the original circuit. I've done the Thevenin steps. I've removed the load, and I've replaced the power supply back in here with a short circuit. Voltage supplies are shorted. Current sources are opened. What I will tell you about that process is that sometimes circuits get simpler and quicker and easier to reduce. This is by no means an impossible circuit. So you put the short in there, and you have your eyeball over here in the blue circle looking into the 27 ohm resistor. And what you've been taught is to go to the opposite end to compress resistance. And what you notice is that R1 and R3 are in series with each other. If you don't believe me, do the touch test. Does the left side of R1 touch the left side of R3? Yes. Do the other two sides, the right side of R1 and R3, touch? No. They cannot be in parallel. There is a 150 ohm resistor in the way. As such, we add to get 75 ohms, which produces this drawing right here, and a new relationship between resistor 1,3 and R2. Those two resistors are 100% in parallel. That allows us to compress them into this 50 ohm calculation over here. I've decided to use the product over sum rule, but you could use the 1 over rule for calculating parallel resistance just as easy. Having made that calculation at 50 ohms allows me to plug the 50 ohms back, and I'm left with nothing but a simple series circuit. And that's how you calculate R Thevenin. You add R4 to R1, 2, and 3 for 77 ohms. Now, continuing on, Part 2 requires you to find the Thevenin voltage out there. As you can see in the circuit up at the top, there is a floating resistor. I have removed the load, so that resistor is basically floating in the wind. Now, before I find V Thevenin, which is located right up here across this gap, I have to come to terms with what voltage is floating out there. And I want you to notice that the floating resistor, R4, up at the top, it has no current. And so the voltage that we need is actually sitting over here behind it. This will be the case. There'll be one of two cases. There'll either be a parallel resistor sitting out there directly across the opening where you find V Thevenin, or you're going to have the situation that you have here. Now, if you struggle with understanding, well, how does R2 have a voltage out there? Well, let me ask you this. Take a look at the circuit in red. If I told you that you had a 10-volt battery and 4 resistors, which never connected to a complete circuit, what would the voltage out here be? And I hope that your answer is the battery floats to the gap. Now, your battery in your circuit won't float to the gap, but the voltage of R2 located up here will definitely, up at the top of your circuit, that R2 will actually float out to the gap. That open circuit is known as Thevenin. That's what we're going to be trying to solve for in the next circuit. So as you look at part 2 for finding Thevenin, look at your new circuit. You can see that I've highlighted the spot where R2 causes the voltage to float to pins 1 and 2. So what we actually have to solve is a simpler circuit than what we started with. We have a complete series circuit. If you look at the circuit with the check mark, it's a simple series circuit with 3 resistors. And the quickest way, and by the way, here's the reason why you learned voltage divider, because if you want, you could go and add all the resistors and you could use Ohm's law, or you could just use voltage divider. This calculation that you make right here in the green circle is voltage divider, and it calculates Thevenin for you extremely quickly without calculating the current in the circuit, which we're not interested in. What are we interested in? We want to know what Thevenin is. Well, Thevenin is 33.33 volts. What this means is that when you have your Thevenin circuit, at the gap here, when you plug your load in, your load is going to have a 33.33 Thevenin voltage and a 77 ohm resistance sitting in front of it. And you have now successfully completed Thevenizing your first circuit. Congratulations.